This is USMLE QA, USMLE material presented in a question and answer format structured similar to the first aid for the USMLE Step 1 book.
Question: what is non-homologous end joining? Answer: non-homologous end joining is a process that brings together the two ends of DNA fragments to repair double-stranded breaks. Homology is not required in this process and part of the DNA may be lost or translocated. Question: what is homologous recombination? Answer: homologous recombination is a process that requires two homologous DNA duplexes in which a strand from damaged dsDNA is repaired using a complementary strand from intact homologous dsDNA as a template. Defective in breast, ovarian cancers with BRCA1 or BRCA2 mutations and in Fanconi anemia. This process restores duplexes accurately without loss of nucleotides. Question: what is the difference between non-homologous end joining and homologous recombination? Answer: non-homologous end joining is a process that brings together the two ends of DNA fragments to repair double-stranded breaks without the need for homology. Part of the DNA may be lost or translocated. Homologous recombination, on the other hand, requires the presence of two homologous DNA duplexes. A strand from damaged dsDNA is repaired using a complementary strand from intact homologous dsDNA as a template. It restores duplexes accurately without loss of nucleotides and is defective in certain cancers and genetic disorders. Question: what are some genetic disorders associated with defective homologous recombination? Answer: homologous recombination is defective in certain genetic disorders such as breast, ovarian cancers with BRCA1 or BRCA2 mutations and Fanconi anemia. Question: can you explain the process of homologous recombination in more detail? Answer: homologous recombination is a process that requires two homologous DNA duplexes. The strand from the damaged dsDNA is repaired using a complementary strand from the intact homologous dsDNA as a template. This process restores the duplexes accurately without loss of nucleotides. The repair process begins with the resection of the damaged DNA strand, which creates a single-stranded DNA region. The complementary strand from the homologous DNA duplex that invades the single-stranded DNA region and serves as a template for repair. The repair process is then completed with ligation, which joins the two strands of DNA together. Question: is non-homologous end joining a more error-prone process than homologous recombination? Answer: yes, non-homologous end joining is generally considered a more error-prone process compared to homologous recombination. This is because non-homologous end joining does not require homology, which means that it can join two ends of DNA fragments together regardless of whether or not they have similar sequences. This can lead to the loss or translocation of DNA sequences. Homologous recombination, on the other hand, uses a template from a homologous strand of DNA to repair the damaged strand, which results in more accurate repair with less chance of errors. Question: what are some implications of defective homologous recombination? Answer: defective homologous recombination can have several implications, including an increased risk of certain types of cancers and genetic disorders. For example, in breast and ovarian cancers, defects in BRCA1 or BRCA2 genes, which are involved in homologous recombination, are associated with a higher risk of developing these cancers. Similarly, defects in homologous recombination in Fanconi anemia can lead to increased chromosomal instability and a higher risk of cancer. Additionally, defects in homologous recombination can also result in a higher susceptibility to certain types of DNA damage, such as radiation-induced DNA damage. Question: how does homologous recombination repair double-stranded DNA breaks? Answer: homologous recombination repairs double-stranded DNA breaks by using a homologous DNA duplex as a template. The process begins with the resection of the damaged DNA strand, which creates a single-stranded DNA region. The complementary strand from the homologous DNA duplex that invades the single-stranded DNA region and serves as a template for repair. The repair process is completed with ligation, which joins the two strands of DNA together. This process is more accurate compared to non-homologous end joining because it uses a homologous strand as a template, which reduces the chance of errors.
Thank you for watching our Q&A format video. We hope this helped you learn, review, and retain knowledge needed for the USMLEs. For more information on this topic, check out the link in the description. Now, if you want to take your USMLE prep to the next level, be sure to check out all our courses, which are structured to follow along with the first aid for the USMLE Step 1 book. You can find us at usmleqa.com. And if you're watching this on YouTube, be sure to like and subscribe.